Welcome everybody to TensorFlow Community Week Uyo. Okay, thank you everybody for joining. And we are starting right away. We have about few seconds left to official kickstart. So our speaker is here already, Felix Samuel Nanor, which is going to be taking us on the introduction to TensorFlow. Okay. So before we proceed, I would like us to unmute yourself, and then you can say your name and where you are joining us from. Okay. So my name is Victor Jacob Asuko, and I'm the co-host and organizer of TensorFlow. And our mission is to enable you to have this TensorFlow skills, and we want everybody out there to be able to use AI and then solve problems in their caption. Okay, so Daniel, it's a good take on next.
Hey guys, what's up? Yeah, my name is Daniel. My boss, Victor, is the organizer, and I'm the co-host of TensorFlow. Also, I'm a machine learning engineer. I've been doing AI for a very long time. Oh, I've seen some people that I know here. Some people from our old boot camp. Wow. Sorry to do this. Siphon. Oh, wow. So people really want to go find life. I'm really happy for you.
Good evening, boss.
Hey, what's up? You haven't collected your certificate for your last boot camp.
How are you? Nice seeing you here, sir.
That's not what I'm saying. You haven't collected your certificate. What happened? Anyways, that's not what I'm doing. So, yeah, what am I saying? That's all right. My name is Daniel. I'm learning machine learning.
You can all turn on your cameras, okay? You can turn on your camera. So it's already so let's continue. Okay. Okay, so starting out, we are going to start with let me share my screen. Okay. Okay, we have let me share my entire screen. Okay. So can you see my screen? Please confirm if you can see my screen.
Yes, I can.
Okay. So today we'll be looking at one of the first steps in understanding TensorFlow. One of the first steps in understanding TensorFlow, knowing what TensorFlow is. Okay. And that was the more reason, since we are just starting out this bootcamp. Today we'll be looking at we are going to have an overview of TensorFlow. What is TensorFlow? What can TensorFlow be used for? If we are interested in machine learning, what are the processes, what are the steps that we can use to build machine learning models or deep learning with TensorFlow? According to Google, the main goal and aim of TensorFlow was to instead of having building your code differently and then having your product differently. TensorFlow allows you to bring all these complexities into one program. So when you are experimenting it, you can actually take it down to a new product. Okay. So without much waste of time, our speaker, Felix Samuel Nanor, who is a machine learning engineer, a passionate computer vision engineer, and from Ghana, will be taking us on the introduction to TensorFlow. We'll be talking about the steps involved in TensorFlow. Okay, so Felix, or you can call him TechWatt, is a YouTuber, and by the end of the day, the link to the slides and the presentation will be made available to everybody that is here. Okay, so at this point, I'll hand over to our speaker to take on from here. Okay, so Felix, are you here?
All right. Can you guys hear me? Am I on mute?
Okay.
Hope everyone can hear me.
Everyone can hear me. I can hear you.
I can hear you.
Okay. So awesome meeting you guys once again. It seems there are some faces here I've met before. Some we are new to me, and it's all good. So I said earlier today I'll be taking you through the introduction to TensorFlow. We'll learn the basis of TensorFlow and what you can achieve using the TensorFlow, which happens to be a deep learning framework from Google. So I'll start just sharing my screen, because I think everything is going to be straightforward. I hope my session is being recorded, right?
Yes, it's recorded. Yes.
Oh, okay. Fine. All right, so I'm sharing my entire screen so that we can begin everything from scratch. Is the screen visible now?
This
Okay. Can everyone see the
Yeah.
screen?
Yeah.
Yeah, that's fine. Victor, don't worry. We can still do it. Okay, so as said earlier, my name is Felix Sam Nanor. I'm AI/ML engineer, and I'm from Ghana. I'm also a YouTuber who teach some of these stuff we'll be discussing here on YouTube. I think even most of you or half of you know me already. Daniel is also my guy, so I think I don't need much introduction, right? Okay, so this is how we are going to do it. We'll go through a theoretical session, and then after that, every concept that I've discussed here, I'll put that into coding. I'll explain it. There will not be much of coding because this is introduction to TensorFlow, but I'll make sure at the end of the day you get the basic and the building blocks you need, which are the main thing or the key thing to your success with the TensorFlow deep learning framework. Okay. I hope you guys can see the slides, right?
Very well, very well. We are seeing everything. Sir.
Right. Okay, that's good. So first of all, we start off with the introduction to TensorFlow or overview of TensorFlow. What is it? Okay, so we have been hearing TensorFlow. Once you are in the AI scene or you are doing something related to AI, it's of no wonder that you come across this library called TensorFlow or this framework called TensorFlow. Ton of times, not once, not twice. Always, when you see codes, you'll be seeing something like TensorFlow or TF. You start seeing immediately, you start seeing things like that, there is something TensorFlow going on right there. Okay, so we'll be looking at this. What is TensorFlow? Okay, so right from the start, TensorFlow is an open source machine learning framework developed by Google. Okay, so nowadays we've been seeing a lot of AI things right there, and this AI can never be done without a framework what backing it. Okay, so Google come up with TensorFlow, which is just a library in Python. We just call them libraries. Okay, that you use to manipulate certain tasks. So let's say, for instance, you want to maybe create a tensor or multiply two tensors together. Okay, you don't have to maybe code everything from scratch. This framework comes with what functions you can leverage on by just filling certain parameters.
Hello?
uh,
Hello,
By just
Yeah,
Don.
filling.
please, Mr. Prince, hold on. After everything, you are going to
Don, I'm not
ask a
here.
question.
I'm not seeing your screen. I'm not seeing. But I'm not seeing your screen. That's what I'm just saying. I need to point out that.
Log out and log in again, please. Felix, can you hear us?
Yeah, I can hear you guys.
Prince, please log out and log in. I'm seeing his screen very well.
Please, since the session is being recorded, we should make sure that maybe the level of interactions and the level of obstructions be decreased so that it will not affect those who watch it. Let's say again. Okay, so I'll proceed. Where did I even stop? So I said, okay, the framework just allows you to perform certain functions or certain tasks with ease. Okay, so for developers out there, they mostly we consider this framework as libraries. Okay, because they have what functions that we just have to fill parameters to do something. So I'm saying, for instance, you have two images, which are images are nothing but matrices or numbers. You want to multiply together. These functions what gives you a function to just fill in certain parameters to perform these tasks for you. Okay, so that's what a library or a framework helps you to achieve. So in the field of AI, we have different libraries, and sometimes it becomes a matter of choice or even to learn both of them. But I think the one which has more name is the one we are talking about, TensorFlow, which is developed by Google. Okay, so the primary use of TensorFlow is for building and deploying deep learning models. Okay, so from the starting, don't be confused. They said it's a machine learning framework, but we all know machine learning and deep learning are just subset of one another. So we can't do with machine learning whilst not having knowledge about let's say deep learning. Okay. The next step is that TensorFlow supports a wide range of applications, including computer vision, natural language processing, and speech recognition. And mostly, this is what AI is about. If you see AI, is either you are using ChatGPT, give it a prompt, and then it come out with some text for you. So if TensorFlow is supporting this, why not learn it and leverage on it? Speech recognition is one also good field that you can use TensorFlow for. They give you functions to perform all those steps. Computer vision, which is also one big field now, making waves, making the computer giving it's like giving the computer eye to see. So TensorFlow also have support for that. So I think it's a good thing, and it's a library which is very worth it to learn as a beginner or as someone who wants to step your foot in the AI industry. Okay, so this is the introduction to TensorFlow, and this is a brief history about what TensorFlow is. But on the field or in the AI industry, there are other contenders too. Like you ask, okay, if I don't learn TensorFlow, which one should I learn? That's where some other libraries like Agiles and PyTorch also comes in. Okay, so they are also equally good frameworks that you can use hand in hand with TensorFlow, or you can choose any of them. But choosing uh let's say a deep learning or AI framework also depends on one, your company you are going to work for, your targeted company. Because some companies use one or the other. Okay, some companies also use both. So sometimes choosing between them have to do with on and off. So like you have to just think, or you learn both of them because they have kind of similar APIs. Okay. Okay, so that's it. Now we'll look at how we can install TensorFlow. Okay, So TensorFlow supports all these major operating systems, like you are using Windows, you are using Mac or Linux. These are the major operating systems. TensorFlow have support for all of them. Okay, TensorFlow have support for all of these operating system, and this is a good news. Okay, it's not like the Windows guys can be using it and we the Mac guys cannot use it, or we the Mac guys can use it and the Linux guy cannot use it. Okay, so apart from TensorFlow supporting this framework, TensorFlow can support both CPU and GPU. Okay, and mostly when you are using these AIs, you prefer to use them with what GPUs because it accelerates your performance and speed up your models, so you get quick results. But TensorFlow just have support for both of them. If you choose to use CPU, it works great, just that the latency is very high. All right. Then from there, you can also use TensorFlow. If you are familiar with Docker images, Docker containers, you can run it as a Docker container via the Google Cloud platform, and you can use it. So that's another way. So this is just theoretical aspect. I'll take you through how to perform the installation. Look at how you can do it on the official TensorFlow site. Okay, so now see we'll get to understand tensors and TensorFlow architecture. Okay, so why tensors? Because we are used to NumPy. If you are not used to NumPy, NumPy is also there. That helps you to manipulate data or manipulate arrays, matrices, scalar data, and also vectors as well. Yeah. But why tensors? Okay, so I'll explain why tensor when we get to the coding aspect of it. Okay, tensors are n-dimensional arrays that can represent scalars, vectors, and matrices. Okay, so the n here means that you can have numerous dimensions. Okay, so it can be a higher dimension, 2-dimension, 3D dimension tensor, and we'll explain all of those in the code. All right, so this is what we'll be covering today. The basic TensorFlow operations we'll be covering today. And you have to take this very serious because that's the basic and you need that to excel in your TensorFlow journey, okay? So we'll be covering things like constants in TensorFlow, variables in TensorFlow, and placeholders. But placeholders are deprecated in TensorFlow, so I don't think we are going to even talk about it much. Okay, so we'll look at constants, why they are immutable, and I will just teach you that, how to, you understand what it means by being immutable. We'll look at variables, and we'll also look at how to perform some basic mathematical operation with TensorFlow. These slides will be made available for you because I don't think there is anything fancy in the slide, okay? So we just get our hands dirty and look at how we can do whatever we've covered in this particular slides. So we'll look at how to perform addition, subtraction, multiplication, reshaping, slicing, and manipulating tensors. Okay, these things are kind of very, very important. Reshaping, slicing, and manipulating tensors. I will also look at maybe graph and sessions. Okay, so I will take you through all these steps. Then we'll come back and look at our conclusion notes. Okay, so that's all for the slides. We'll quickly jump into it. And as we are learning along, kindly also jot your questions down because at the end of the day, I'll be taking your questions and I will be teaching ourselves, we'll be answering ourselves, and we'll see how it goes. Okay, so in order to include everyone in this particular coding, we are going to do the coding via Google Colab, okay, or Google Collaboratory. So I'll just search Google Colab and we'll use that for the coding. I'll also open maybe the TensorFlow website so that we'll use that to learn how to install TensorFlow. Okay, so whilst the Google Colab is loading, let's talk about let's speak about how to install TensorFlow. You get your new computer as a beginner and you want to install TensorFlow. Which steps should you follow? Okay, so before you install TensorFlow, the first thing is to come to their site and look at the versions of Python they support, or the versions of support, okay, because they have support for these languages. So when you come, you just click on install, and this will give you a brief description about what you need to do to install TensorFlow. Okay, so the current version of TensorFlow now is TensorFlow 2. Okay, in the previous years we've been using TensorFlow 1, and TensorFlow 1 also have some flaws and also some packages it supports. But since then they've moved on to TensorFlow 2. They've made some major changes in their APIs, and now TensorFlow 2 is the one everyone is using. Okay. All right. So to install it, I told you earlier they support Mac, they support Ubuntu, and also you can install them on Windows as well. So right here, they point out a Python version for Mac users. Okay. So they are saying from Python version 3.8 to 3.11. When you are using this Python version and you are a Mac user, okay, there is no GPU support for you. So you will not, when you install TensorFlow, you can use it all right, but you don't have GPU support. When you have GPU with your Mac, you can still use it. You can do every computation on only your CPU. Do you get it? Okay. Then for Ubuntu 2 is the same thing. They give you whatever you need. I don't use Ubuntu, so those of you who have been using Ubuntu, you can maybe know what WSL2 via Windows and whatsoever. Normally with Windows, which I have been using to install TensorFlow and use GPU, you have to install the C++, this one package. Okay. So is it a Visual Studio Code? You have to install Visual Studio Code with C++. Okay, so that you can have access to TensorFlow and use your GPU for development. We'll scroll down to that. But if you are a number guy who just wants to do pip install TensorFlow straightforward, then all you have to do is to upgrade your pip. So you create your project, then you do pip install hyphen upgrade pip. You upgrade your pip so that your pip will be up to date. And the next thing you do is to pip install TensorFlow. That's it. So this is for CPU support only. Okay. When you do this, it's not going to support GPU. For GPU, there are extra steps you need to follow. Okay. But for GPU, just do this and that's all. Okay. Then for people who will be using Docker, okay, you want to run TensorFlow via Docker. If you are familiar with Docker, when you anytime you type Docker pull, that means you are downloading a Docker image from the Docker registry. So Docker pull, then you give the Docker this one, the ID to the whatever you want to download. So you are saying you want to download TensorFlow and you want the latest version of it. If you don't want the latest version, then you have to give the particular ID you want to download. Then from there, in your doc terminal, you can do Docker run. You give it the port. So mostly this is the port for TensorFlow. You have to make sure you associate the same port to it. Then you give it the name, and this will just start running. That's if you are familiar with Docker, but only few people use TensorFlow with Docker. Okay, so that's it. So that's for the installation. Okay. After installation, then you can see build your first ML app and so on. Okay, but where we are going to use it today, we don't need to install it because by default it's being installed. Why is the Colab not loading? By default, it's already there on Google Colab, TensorFlow, and mostly other packages. Those big packages are pre-installed. So when you are using Colab, you don't need to go back and install TensorFlow again. It's already installed. You just have to import it and start using it right there. I don't know why my Colab doesn't want to open today. Let me try opening. So let's say new notebook. That should be fine.
Okay, everybody. So, well, um, coming back before, I'm going to talk this first to engage the chat session. We can do a chat session.
Hello, can you guys hear me?
Yes, we can play.
I don't know. I don't know why my Chrome just zipped on its own. I just don't know why. I don't know why. Okay, so we are still on it. Let's.
All right.
So it seems we are connected. Is the font size okay for you guys? Can everyone see? Can everyone?
Actually, cannot see you. I don't know. I've not been seeing. I don't know why, whether it's my network or whatever. But I just hope that the record will have the slides and the
You,
visuals.
I'm
But me, I wasn't seeing.
okay. I'm coming. Let me.
I can't see the screen.
Okay, I'm coming. Sorry. Is it visible now?
It's
Yeah.
It's visible, right?
yes.
Yes, it's visible now. I can see. Yes,
Okay, so let me
I can see.
take it over at Colab. So I said when you come to Colab, right? Google Colab. It's free. You just have to search it, and when you come over
Sorry,
here,
I didn't know. I missed how you got to Colab. Oh, sorry. So I wanted to flow together with you.
so let me do it over again.
Thank you very much.
Okay. So for Colab, you just have to go to your web browser and just search for Google Collaboratory or Google Colab. Okay. So when you open it, something like this will come, and click on Welcome to Google Colab, or you can just click on Google Collaboratory. So it will take you here. You can see I have some existing notebooks right here. But if you want a new notebook, which means you are going to do a new project, you can just click on New Notebook. But I've already started this notebook called TensorFlow for Beginners just right now. So I can click on it and it will open that same notebook for me. In your case, just click on new notebook and get started there. Okay. And I said, okay, when you come to TensorFlow, mostly I say TensorFlow, when you come to Google Colab, mostly Google Colab gives you access to GPUs, some free GPUs you can leverage on. So you just have to come to runtime, change your runtime, okay? So over here, you can change runtime and then you can select the T4 GPU and you click on save. So when you click on save, you can leverage the GPU. In my case, I've exceeded the usage of my GPU, so I'm not going to use the GPU. All right. Next thing to know is that TensorFlow comes pre-installed in Google Colab. Are you guys with me?
Please, I will click on the runtime. What next do we click on?
Click on change run. Have you clicked on that? Then you see some
Yeah.
you see some radio buttons. Just click on T4 GPU. Have you done that?
Yes.
And click on save.
Okay.
Have you done that?
Yes.
Now you over here you can connect. Click on connect. You can go ahead and connect.
Where?
Have you done that?
No.
Are you doing it?
Where should I connect from, please?
On your right, but on your right side, you can see some connect button right there. Have you seen it?
Wait, can you bring your cursor to the place?
Can you see where my cursor is? You have to see connect. The mine is connected already, so the connect keyword is not there.
Okay, I'm
Have you
connecting.
Oh, okay. So when it's done connecting, you see a success tick mark right there, and that's it. You can start coding, and
Sorry
you'll
to
be
draw you
using the.
back. Sorry to
Okay,
draw you
it's
back. You
connected.
said
Thank you.
from change runtime. From change runtime, what else? Please.
You can see T4
Python
T4
3
GPU.
and R. I saw Python 3. Okay, T4 GPU, yeah.
Yeah, just click on check that radio button.
Okay,
Have you
after
done that?
T4 GPU, I will now press save, right?
Exactly.
But then there is this one runtime type. Is it Python 3 or R? I should leave it that.
You know, if you should put
Uh,
it on Python 3 because you are using Python 3, right?
Okay. Okay, save.
Now you can connect. Are you done?
How do I connect?
Yeah, haven't you seen the connect button right at your
Connect
right?
T4.
Yes.
Okay. How do I connect? What should I press?
Just click. Or is
Like
it connected? Or is it connected
no, I'm seeing
already?
it's like a drop down. I'm seeing connect to hosted runtime T4, change runtime type, connect to custom
So
GCV, connect.
okay, you just click on connect to hosted T4 or something.
Okay. Connecting.
Okay, that's fine. Okay, so if you are connected, that's it. You can just continue coding. But sometimes if you are not using if you are not going to use GPU in the type of coding you are going to do, you just don't need to use the GPU because that GPU they give to you is for some time. It's time based. It renews, isn't every 24 hours. I don't know. I don't really know the timing, but I think every day when you use it and it's up to like mine today. It seems I've used it, so I don't have it now. Unless maybe tomorrow they will give me access to it again. Okay, so I said earlier, almost most of the libraries or most frameworks are installed by default on Google Colab. So you don't have to install it. Okay, they are by default installed. TensorFlow, for instance, is by default installed. But if you don't know and you want to install it, you can just write pip install and the name of the library. So just as we've seen on the TensorFlow website, you can just do pip install TensorFlow. And when you run it, it will go ahead and install it, but it's already installed. So you can see all the requirements are already satisfied. So that's why I told you guys it comes pre-installed on Colab. So you don't need to install it again. All right. So other libraries do the same. So just now continue and import TensorFlow. Okay. So we'll just use the import and then we type TensorFlow. and over here we import TensorFlow. But normally, mostly we import it as TF, and this TF is just an alias. Okay, you can use it anything at all. You can import it as your name. So import it as SA, anything. The main reason why they use TF is that TensorFlow, so T and the F. Okay, so it's an alias so that you don't have to type TensorFlow dot to call all the methods if you want to use them. So import it as what TF, and that's it. And you just have to run that cell and it will load. When you get a success tick mark, that means TensorFlow has been imported. Okay, so TensorFlow has been imported, and that's cool. Now we'll start off by looking at TensorFlow constants. Okay, so it's like you are learning a new programming language where you have variables and those stuff. So in TensorFlow, we'll take it one step after. So we'll look at what TensorFlow constants. So let me put it down here. Someone background is very noisy. Find out that person and let's tensor. Okay. So TensorFlow constants. Okay, so that's the first thing we'll be looking at. Okay, we'll be looking at TensorFlow constants. What are constants in TensorFlow? All right. So TensorFlow constants helps you to create tensors, okay, or create TensorFlow tensors. Okay, so anytime you think of tensors, just think of them like if you're familiar with NumPy arrays and all those things, okay? But in another dimension, we call them tensors because they have the capability of what leveraging on what GPUs, and I'll teach you all of that, okay? So to create a TensorFlow constants, all you have to do is to maybe give it the name. What name are you going to store it in? Let's say a variable. So I can say TF or const data. Let me just call it const underscore data. And this will be equal to TF dot constant. Okay, TF dot constant. All right, because the reason why we are using TF is because we have imported TensorFlow as what? TF. And inside it, you bring your parentheses. So in this parentheses, you can now go ahead and create your tensors, okay? And these tensors, you can create them any number of dimensions you want, okay? But mostly, since most of us are beginning, or most of us this is our first time, or I don't know, we'll be doing one dimensional, maybe some will do some multi-dimensional tensors too as well, and I'll teach you how to maybe operate all of them. So in the list form, we give it maybe we create our first tensor. We can say 4, 5, and 6. So this is our first tensor, okay, and we can go ahead and execute this. All right, and even under it, when we call back our const underscore data, this will return some information for us. This is telling us that, okay, this is a tensor. It's a TensorFlow what? Tensor. It has the shape of what? 3. So you can see it has 3 shape. Okay. 3 shape, the shape of 3 by nothing because it's one dimensional. And the data type is what? Int32. So this is 32 bits. Okay, in the form of NumPy array. If this has to be represented in the NumPy array form, then it's what? Just one dimensional array, and it's also in 32. So the TensorFlow framework is even drawing your mind back to NumPy because it knows that we are using NumPy before TensorFlow comes in. Okay, so you are familiar. If you are familiar with NumPy, then whatever this tensor is giving you is the same as the NumPy representation here. Okay. Okay, so in the constant parentheses here, there are certain things you can add. Okay, let's say maybe I don't want to use data type to be int32. I want to change the data type. Okay, I want 64 bits to work with, and you should know the higher the bits, the more power and more computational expensive it becomes. So that's one fact you have to also live with. So you guys should should know about that. Okay, so let's say you don't want the data type which is int32, you want to change it. You can just do d type, and this d type is equal to there are 2 ways you can assign it. Okay, so you can just write it in a string format, maybe float 64. You can use int 64, float 64, any of them. So you can just do it this way. And you can see now our D type have changed to what? Float 64. Okay, but the most convenient way, I won't say most convenient. If you are good with TensorFlow, then you can just do tf dot what if is it float 64. You can just choose it right here. tf dot float 64, so that you don't have to bring the string in there, and this also works. Okay. All right. So now we learn how to create what? One-dimensional TensorFlow constants, and I'll teach you how to check even the dimension. Maybe you can't with your eye, you don't know this is one dimensional, so you can just look at it and know. But if you have maybe many dimensions, maybe let's say 3 dimensions, 4 dimensions, it sometimes, unless you have been doing it over and over, but sometimes it becomes very tricky to just look at it and say, okay, this is 5-dimensional array. Okay, so I'll teach you how to use TensorFlow to assess the dimension. Okay, then there is one important thing here you can also assign, which is the name. Okay, the name of this tensor you are creating. So you can assign a name to every tensor, and maybe you can call this name data or something. You can give it any name. And this is very important. I see most people not doing that, or when you browse through people's code, they don't normally assign the name, but it's a good practice to assign the name. Because when you are training AI models, okay, when you're training AI models, these models have parameters, hyperparameters, such as maybe the learning rate, epochs, and so on. And those things are to be monitored. Okay, so once you are training the model, you can monitor those things. On TensorFlow, we have something called TensorBoard. TensorBoard allows you to monitor the progress of your training. What is going on well? Is your model overfitting? Is it underfitting? All those things you can monitor. So you can use this name parameter. Okay, so when you assign name, let's say data, and I want to monitor data for maybe this particular tensor I've created, I can just use this name parameter to know about it and use it to monitor. You can also use it for debugging case. Okay, maybe you want to debug something which is wrong with this particular line of code or this particular tensor you've created. You can use this particular name. Okay, so that's one thing you have to know, and these are the most important parameters the tf.constant takes. Okay, but the first thing to know before even creating a TF constant, are you guys with me? Am I audible?
Yes, we
Yes.
can hear you.
Oh, okay, that's fantastic. The first thing to know before even doing whatever we are doing is that what TensorFlow constants are immutable. Okay, and when we say immutable, that means once you've created these TensorFlow constants, you can't assign a new value to these values you've already initialized, okay, or to these tensors. All right, but before I even further uh, maybe explain that, let's look at some couple of things. Let's look at how to check the dimension of this particular tensor. How do I know the dimension of the tensor I've created? So you just have to type the name of this thing, the variable you are storing your tensor in. So const data dot shape dot number of dimensions and names. Okay, so just like this, and this will tell you, okay, this is a one-dimensional what tensor we've created, and I can change it to 2 dimension by just increasing the number of this here, and now you can see it has become what a 2-dimensional tensor. But let's just use 1-dimensional tensor. Moving on, we'll create maybe 2-dimensional tensors and learn how to manipulate them. So that's how you can check for the dimension. I think in NumPy we just use maybe const underscore data dot endnames or endname. In NumPy this works. I don't know. Okay, so this works in TensorFlow as well. So you can just do it number of dimension. That works in NumPy too greatly. All right, so that's how you can check the number of dimension you have, because it's kind of very important. Okay, you have to know how many dimension is your data having. In this case, we are just dealing with these numbers. Okay, but let's say you are training image recognition systems and all those things. All those things are numbers. So you have to know how to manipulate. You have to know the dimension of an image before you can apply certain transformations on it. So dimension always comes first, and you have to know the dimension. The dimension, one thing about it, that if you know to when you are designing your neural networks, you have to maybe put in the dimension of your data into those neural networks so that the neural network is aware of the dimension of data you are coming to feed into it. By so doing, it will know how to calculate the computations and every other things you will need. Okay, so that's TF constant. And for the float 64, we are not limited to float 64. We have int 32, int 8, int 16. So we have so many data types, okay? But the higher it is, more computational expensive it becomes. So you have to know that, okay? Okay, you can also check, let's say, the type of the, maybe you are so Pythonic that you want to check the type of your variable. You can do const underscore data. I think these things are not that even needed, but just want to take you. So you can see this is a TensorFlow.python.framework.ops.eager tensor. So it's a TensorFlow tensor that we've created. Okay. All right. Now let's look at how to access values in a tensor. I'm not forgetting about tensors being immutable. I'll explain that at the latter end. So let's look at can you guys still see?
Yes, we can.
Okay.
Yes, yeah.
All right. So now let's look at how to access values in our tensors, because looking at this is just like an array. For me, as an ordinary Python programmer, I see this to be an array or list of numbers. Okay, let's see how you can access the individual values. Okay, so let's say I want to access 4, I want to access 5 and 6. It works with indexing. Just if you are familiar with Python indexing, you can just access it. So let's say const data in the index of 0. Let's see what it will bring up. You can see this gives us what? NumPy equals to 4. So the first value here is 4. You can see. So on. You can just access it. You can maybe, let's see if you can slice it from 0 to the end. So let's say you want to access all the values. Okay, so you can see 4, 5, and 6, and that's it. So Python slicing works on these tensors. You can just slice them and get the individual values. Okay, so this is one way of accessing them by indexing. Okay, and speaking of index, we are all familiar. The first index is always 0, 1, and 2. Okay, even though there are 3, that's the fun of programming. It always starts with 0. All right, so now we know how to access them. You can also iterate through them by using maybe for loop for I in is it const data. So you can iterate through them and just print your I. Maybe you want to, it's a big tensor, you want to iterate through them and take it. So print I. This will just go ahead and list all the data in that particular. So you can see we have 4, we have 5, and we have 6, and it's float. So there are decimals in front of them, 4.0. So that's how you iterate through them. Okay, so now let's look at something. If our tensor now becomes, let's say, two-dimensional tensor, are we still going to access the elements the same way? Okay, so in that case, things become tricky. When it is two-dimensional, are you going to still access values the same way? Let's see. Okay, I think I didn't create the two-dimensional. Let me do it this way. Maybe I copy this one in the same, this one, then I paste it twice. Okay, and I can change these values now from 1, 2, and maybe 3. Okay, so now let's go. Let's see. So this is still a two-dimensional array or a two-dimensional tensors. I don't know. I always confuse them with arrays because we are used to arrays. Okay. All right, so assessing maybe multi-dimensional or n-dimensional tensors, how do we assess them? So let's say now we have 4, 5, 6 in one bracket. Okay, we have 1, 2, 3 in another bracket. How can we now assess them? Okay, so let's say I want to assess the first value here, tensor at index 0. Let's see what I'll get. So you can see this brings what the first array, okay, not the individual array. So this brings the first array. The same way when I do maybe -1 to get the last, what am I doing? -1 to get the last tensor, you can see it gives the 1, 2, 3, or this, yeah, 1, 2, 3. Okay, so now how do you access the individual values? So let's say, for instance, in my tensor, I want to access 4. Okay, so now your slicing has to also be multi-dimensional. You just don't access you have to choose which one, the tensor, which dimension, which one do you want to access the value from. And since we know it's 2-dimensional, maybe I want to take the first tensor in my variable, and this first tensor will be the values 4, 5, 6 or so. Where is it? 4, 5, 6. And now let's say I want to access 4. I have to bring another parenthesis and then choose, because 4 is at what? Index 0. Okay, and you can by so doing you can access, you can see we can access 4. Okay, you can go ahead access 1. So that's something you have to know about how to assess multi-dimensional level tensors. Okay, for one-dimensional tensor is straightforward, you can just index, but when it becomes multi-dimensional, then you have to know how to assess them. Okay, so now let's go to the part where we'll conclude on TensorFlow constants, and that's to say the first thing you have to even know before doing whatever we have done. Okay, so the first thing you have to know is that TensorFlow constants are what? Immutable, and that just means that, okay, the values I've declared cannot be what? Changed. Okay, so let's say, for instance, say x is equal to tf dot constant, and I give a one-dimensional axis 7 and 8, C7 and 8 here. I don't want to fill up the D type. By default, it will give me it's this type. So I create a constant with TensorFlow constant like this, and I want to maybe change the number 6 to maybe 5. Maybe I realize that, okay, this is my tensor here, this is my tensor value here. The value in my list here should be 5 and not 6. Let's see how we can change it. So when you do x is equal to, first you have to assess it, and by looking at it, once we know it's a what? One dimensional, we know it's the first thing. So we'll just assess the first thing, and then let's try to assign a new value like 5 to it. So you can see we got what? Type error. TensorFlow framework object does not support item assignment. So this is even very descriptive. That means constant being immutable just means you can what? Modify the values in them once they are created. Okay, so that's the first rule of thumb you have to know. So when you are creating constants, you have to know that, okay, the values held by these constants cannot be changed. Okay, so when you are training a neural network and you decide to maybe use constants instead of variables and those things, you have to know with the constants you can't change those value over time or during what? Training. Okay, so you have to know where to use them. You have to assign values or tensors that cannot what? Be changed. So that's why we got this error here, and I just want to show you that. Okay, all right, so now let's see how to convert PyTorch is it tensors to NumPy array. Okay, because these conversions happen all the time, and guys, you have to be very serious with this one. Converting tensors to what? NumPy array, and converting NumPy array back to tensors is very important. Those in the computer vision field know what I'm talking about. When you are working with images, okay, let's say when you use libraries like OPCV, for instance, take images in the NumPy format. Okay, so when you have a tensor image in a tensor format, you have to make sure you convert that image back to what? NumPy format before you can use OPCV to read it. And this happens because when I'm training my neural network with TensorFlow, I have to shift every data I have to what tensors. The images have to be represented in what tensors, because with that I can leverage GPU and also TensorFlow to what train my model. Okay, NumPy does not support GPU. NumPy have no support for GPU. That's why we have tensors. So with the tensors, you have to make sure you know how to convert between the two of them, so that whenever you need to visualize an image, or you want to visualize something which is a tensor, and the other framework you want to use, in this case, which I'm using OPCV, which only supports what NumPy array, you have to know how to convert it quickly. So I think the explanation is extra clear. Let me just go ahead and teach you how to convert it. So let's use our this X tensor, but before that, let me bring the type of X so that we know. So I'll, or I don't need to print it. I can just type of X. I'll run this, and it tells me that it's a tensor. Okay, so now let me convert it here to NumPy. So let me do NP data is equal to what's the name we've given it, X dot NumPy. That's all. You just have to write dot NumPy to it, and this will what convert it to what NumPy. So at the end, we can also look at type of what NP data, and let's go. So you can see now is what a NumPy array. Or okay, so now this is what NumPy array, and this is how simply you can convert from tensor to what NumPy array. Okay, now you also have your image or your data, if it's video processing, human sound or audio processing, all those things that are just numbers. Okay, so let's say you want to convert this back to, you have it in the NumPy format, you want to convert it back to tensor, just as the NP data we have here. Now it's a NumPy data. Let's see how to convert it back to TensorFlow tensor, which is very also easy to do. So to convert it back to tensor, you have tf.convert to tensor. It's a function, you just have to type it. So let's call this one tf tensor back, and this will be equal to tf dot what convert underscore to tensor. So inside here, you just have to give it the NumPy array you want to what convert. Okay, so normally when you are writing code and this pops up, this is how you can use it. So you can see, even they give you, sometimes they give you boilerplate code that you can look up to. They explain the data types, whatever you need to do. So it's kind of helpful. You can look up to it. So by now I'll just feed in my np underscore data, and I want this to be converted back to what a Python tensor. I can call this tf underscore tensor to see what I'm having. And you can see we have converted this back to what tensor. If you don't believe it, just look at the type, and you can see it's back to what tensor. Okay, so tf constant, these are the most important things to know about tf constants. Okay, and most of these operations that we've done works with any other form of data you come up with in TensorFlow, but the major thing you have to know about TF constants is that they are immutable. Okay, you can, once you assign the values, you can't change them. Okay, so that's the major thing you have to know. But all these other operations, let's say converting from this to this, works with the other ones. All right, the next thing we'll move on to is what TF what variables. Okay, TensorFlow variables. So I think I'll just make a mark down here. TF variables. Let me write this one. Okay, so we all know, by now we know the limitations of what TensorFlow constants is that they are immutable. That's not actually a limitation, because you might also need them somewhere when you are writing codes. Okay, so now what we'll go ahead and do is that, is there any alternative which is not mutable? And that's where what TF variables come to play. So I can now go ahead and describe a new data val, which stands for data variables, is equal to TF dot what variables. And inside here, just as we are creating the, okay, if I'm spelling variable correctly, just as we are creating the data, you can create any amount of data here, like amount here saying like any dimension of data you want here. Okay, you can create one dimension, multiple dimensions of data you want to create. So let's create maybe let's still hold on to our one dimensional array. So let's start 9 7 6. Let's keep everything simple. So now we've created this. It also takes the D type, the name, and all those stuff. So D type, data type. Am I typing data type correctly? So we can assign this to the TF dot what? The float. I don't love this when I'm coding and this comes. TF dot float maybe 32, or we can even go lower, float 16, and you can also, if here, you can also add the name as well. So it also takes the name. Maybe you call it val data. Okay, so it also accepts everything that the TF this thing accepts. But the major difference is that for this one is what mutable. You can change the values assigned to it. Okay, so let's run this, and whatever operation we have done with TensorFlow constants, you can still do it right here. So data, maybe data underscore val dot number of dimensions. So shape dot ndms. Okay, this will still give you that is a one dim. So it accepts all the operations except that you can change the value. So let's say now we want to change the value here 9 to maybe 0. So that's where it shines. So we can do data underscore val, then in the index of what 0, because first you have to check the index. So the index of our first value here is 0. You have to first assess that, and then you equate it to a new value. And in this case, we set 0. After that, we can just look at our data val once again. Okay, we got some error. This resource variable does not support item row. Really? No. Let me check it. Variables are, I'm coming. Let me first data var. Let me access the data and let me see. Tensor shape, it doesn't give float 16. NumPy 9. Okay. Really, I don't know why, but it's not accepting me to assign a new value to it. Let me look up at TensorFlow. Where is it? So whenever you run into errors like this, just search on their website. They have a search button. So just do TensorFlow variables, and then that particular API will pop up. You can look up to it. So TensorFlow variable, TensorFlow 2. Let's look at it. Okay, so this is how it is. Tier variable, initial value, trainable value. Okay. TF the variable 1.0. Okay. Yeah, so it accepts assignments, because right here you can see they've given it a value 1, and okay, they've used the assign method. So let's try that out. Because here we are just doing it a Pythonic way. maybe a 0. Let's use dot assign. Let me assign 1 and let's see if it works. Okay, so now it works. So that's it. When you run into error, you just have to look at the documentations. Documentation, their official documentation, and it's pretty much it. It's very easy. You can see it's very concise and clear here. You can just look up to it. You look up to some of their example, and you come out with your own solution. So you can't just assess them just as I'm assessing like in a Pythonic way, but you have to use this assign term here in order to assign the value you want to assign to it. So first I assess the value I want to change, which is 9 in this case, and I use the dot assign method and put in the number I want to assign. Okay. Okay, so that's it. You can also maybe assign for multiple values as well, but you have to first make sure you select those values. Okay, so that's the major thing about what TensorFlow variables. All these other operations that we have performed, you can perform them using TF variables, but just that they accept what assignment, other assignment. So maybe you assign a value to be 2. Later on in your code, you can replace that value. Okay, you can assign another value to it. So you have to know, in order to do that, you have to be using what TF variable and not what TF constant. And the term we use for that is what they are what mutable. Okay, if it's immutable, that means you can assign value to it. You can assign a new value to it. Okay. Okay. So the next thing we'll look at is TF placeholders. I will not waste my time even talking about that because that function is deprecated. And what I mean by deprecated is that it's removed. It's being used in Python version, TensorFlow version. Is it version 1? Okay, TensorFlow version 1. But in version 2, it has been removed. Okay, so that's how it works. With time, some of these APIs are being removed, they are being replaced, and so on. So TF.placeholder is not something we are talking about today because it's what deprecated. Sorry for that though. Okay, so we'll move on to maybe array operations using TensorFlow. When you're using TensorFlow, what are some of the array operations you can do? Okay, so in NumPy, we used to maybe do some array operation, join 2 arrays together and those things. Reshape array, which is very important. The reshaping aspect is very important. So we'll look at that. Let me also do that text, and I'll call this array operation. Okay, so over here, let's just define some constants. Okay, so x is equal to tf dot constants, and in here, let's do 1 dimension. 1, 2, and 3. Let's assign a d type is equal to tf dot float 32. And let's give it a name of just x. So let's create 2 of these, maybe x and y, and then we can use them to perform those array operations. So I'll call this y, and I'll call this the name. I'll give the name y. Okay, so they have the same data types. We can change this to maybe 4, 5, and what 6. All right, so now we've created what 2 TensorFlow constants, which are all 1 dimensional. Okay, we've specified that our data type is float 32. And what we are going to do next is to perform some array operations. So first we'll look at how to concatenate these 2 arrays together. Okay, concatenation will perform that. And what that means is that maybe you want to combine these 2 arrays into one big array. Okay, so you want to take the first array and concatenate the second array into it. Okay, so you collapse it, it now become one. The result should be one dimensional. So we'll have at the end we should have something like 1, 2, 3, 4, 5, and 6. Okay, that's what we are going to do. So that's also a very handy thing to do, and it's something you have to also take very serious as a beginner learning TensorFlow. Okay, so let's do that. So let's call it, what will I call it? Concat, or yeah, concat underscore op, which is concatenation operation. And TF, you just do TF the what? Concat, that's all, which stands for concatenation. And inside here, you just have to what? Specify the two what arrays or two tensors you want to what? Concatenate. In this case, we have X and what? Y. Okay. All right, so after this, the next thing is the axis. Are you going to do them column wise or what? Row wise? Do you get it? So we'll do it what? Row wise. We want it to be one long, this one. So you specify axis, and if you want to do it row wise, you just have to put in what? 0. Okay, and that's all. That's all you need. Now we can even go ahead and check this concat underscore op. All right, so this is our result. We take these two different arrays and then we've combined them together. So the end result is that we have 1, 2, 3, 4, 5, and 6 into one different what? Array. And this is what concatenation is about. Okay, let me trick this to maybe 1 and see. Okay, invalid argument. Okay, the reason why we are getting valid argument is that now this is what? One dimensional array, and want to do it what? Column wise. So this will be impossible. Okay, we can't do it column wise. But if it's like you have different normally this happen with images. Images have numerous numbers, in this case called the matrices. Okay, for that one you can do it column wise or row wise, but for this one dimensional you have to always make sure their axis is what? Row wise. Okay. All right, so that's concatenation. That's how you can concatenate two arrays together. Are you guys with me still, or I'm talking to myself only? Oh, okay, that's fine. Okay, so the next operation we'll look at is how to reshape. Okay, so let's say we want to maybe reshape x. Where's x? X, we have it to be 1, 2, 3. Want to reshape it. That's very important. Let's see how we can reshape. So we'll save this to maybe reshaped val, and this is equal to tf dot what? Reshape. So you can see the TensorFlow API is very easy. That they just use their names, tf dot what? Reshapes. Even though some of these names are what? Weird, but for beginner, I think most of them are very friendly. So tf dot reshape, first you have to what? Provide whatever you want to, the data you want to reshape, and we said we want to reshape x. The next thing you do is what? You define your shape. Okay, so in a list form. Okay, so I can just say shape is equal to, and over here you define your shape. Okay, but before you reshape any value, you have to look at how this value can be reshaped. Okay, you just don't put any number. Okay, maybe I have 1, 2, 3, then I want to reshape this into 2 by 2 TensorFlow tensor. It's impossible. You can't reshape this to 2 by 2. So you have to, if it's 4 numbers, you can do it 2 by 2 and it works. Okay, but now it's only 3 numbers, so the only shape we can put this is what? Either 3 by 1 or 1 by 3. Okay, so maybe I can reshape this to 1 by 3. Okay, and that's it. So that's the rule for reshaping. To reshape, if you have been working with machine learning, you work with data in CSV, you are doing exploratory data analysis. Sometimes you want to reshape the data before feeding it into all these machine learning algorithms. You have to make sure that you know the dimension of your data, and you know each and every possible form it can be reshaped into before you pass in the values. If not, you will get error reshaping into some values which the data cannot be reshaped into. So let's run this, and you can see we have reshaped it, and still we have what? 1 by 3. The shape here becomes 1 by 3. And if you look at it, it's now like two-dimensional array. Okay, so let's say now we want to even reshape this into what? Let's try something 3 by 3, which we know it won't work. Looking at the nature of the data, should that work? You can see it's not able. We got an error because it's only 1, 2, 3. Okay, so we can do what? 3, 1, right? Let's see if we can do 3, 1, which is what? Possible. So you can see how we got it now. Is what? So that's reshaping, and it's also an array what operation you can what perform. Okay, so that's how you perform reshaping. The next operation we'll look at is slicing. Okay, maybe you slice data. You want some portion of your data, some portion of your tensor you've created. You need some portion of it. Okay, so let's see how you can slice that. So you can use the tf.slice. So let's do that on our X still, and I'll call this maybe slice underscore var. This is equal to tf.slice. Once again, you can see the API is very simple. Slice, that's all. You are slicing numbers here and there. And inside the slice, the same thing, you have to what? Pass in the data you want to slice. So let's use Y. And there are two things you have to do here. Where you want to begin from, okay? So where do you want to begin your slicing from? This is one dimensional, so we can just use one number. So you can type begin, you specify your begin, and your begin here, you put it. Where do I want to begin my slicing from? Maybe I want to start the slicing from the first what? Number. So when we take Y, the first number is what? 4. I want to start my slicing from 4. And the next thing you have to specify is the size. Okay, how big do you want your slicing? Where do you want it to end? Okay, so that is what? Size. And size, we can equate this to what? Where do we want it to end? So I just want maybe 2 values. So it will start from 4 and end at the last one, or is it the last one? From 0 between 2. How many numbers are between from 0 and 2? That's what you are going to get. So let's get this slice underscore var. Okay, and you can see we have what? 4 and 5, because what is it? We are starting from 0, so 4 and 5. Why should it be only 4 and 5? I don't know. Yes. Okay, so it doesn't include the last index. Okay, but in the normal sense, it should be 0, 1, and 2, which it should be all the numbers. Okay, but since it doesn't include the last number, we are only taking from 0 to what? 2, and that will give us 4 and 5, and not including what? 6. So that's how you slice. Okay, we are slicing this way because whatever we are slicing here is what the data we are slicing here is what? One dimensional. You can see if it's two dimensional, you can put in double values here. Okay, so you can maybe do 0 and 1 pertaining to the array, the particular array you want to target, or particular data in the dimension you want to target. Okay, the size, so you can specify it to be maybe 4, but this in our case is one dimensional. So for one dimensional, you have to make sure there are single values in both the begin and the size. Okay. Okay, so that's all for array manipulation, and that's the important things we need when it comes to array: how to access element, how to slice elements, take some particular portion of some elements. Okay. All right, we'll move on to the last thing, which is some mathematical operations we used to do with our number programming. How can you perform those simple mathematical operations using the TensorFlow framework? Okay, so this particular one, tensors work differently. So whatever we are doing, maybe you can do that in Python. A is equal to this, B is equal to this, do A plus B. But in this case, we are dealing with what? Tensors. They are much different from the numbers we used to do, because they have GPU supports. Okay, so let's perform those normal mathematical operations. For that, we'll just do A is equal to let's still use our X and Y we've defined at the top here. Let me copy them once again. I think I have to format this notebook and send it to you guys for those who need it. math operation.
I'll need it.
Okay. So math operations. Let's look at some of the mathematical operations we can use. You can do in TensorFlow, the simple ones. Okay. So first we define two constants, x and y, and by now, if you are following along, I know you know everything about TF constants. You know what they are, what they can do, what they cannot do, and those things. So we've defined two TF constants, x and y, and the first thing is that we'll try to add them, okay, and see how these values get add up. Okay, so 1 2 3, and we are adding these to 4 5 6. How would they do they add up together? Okay, they do that element wise. So let's see them in action. So I'll call this sum, and sum is equal to what? TF dot what? Add. That's all. Inside here you have to what? Provide the two things you want to add. You want to add x and what? Y. So at the down, we can come for sum, and when we run this, you can see our result. So our result here is what? 5, 7, and 9. So when you add these two arrows, you get 5, 7, and 9. How did he add it? It adds them element wise. So it will add 1 to 4, 2 to what? 5, 3 to 6. Okay. So before you perform these additions, you want to make sure. Okay, let's do this. Let me add one number to here. Let's run this. Let's add the sum. You can see we got an error. Before you add, you must make sure the elements in this part, the two tensors you are going to add have the same dimension, they have the same length. Okay, so that's something you have to know before you try to add them. If not, you run into error if they are not of the same dimension and you want to add dimension before doing that thing. Okay, so I'll run them again. Okay, so now let's look at how to do subtraction, which is also simple. So sub is equal to tf dot subtract. So the API is very simple. Tf dot subtract, you provide what is it? Are we using a and b or x and y? Yeah, x and y. We can just do sub, and it will do them element wise as well. So now it will subtract 4 from 1, which will give you -3. You can see we got it here, and it will do the same thing for the rest, subtracting 5 from 2, 6 from 3. You get it. So that's how it will be. If you want them to, if you want it to subtract these ones from these ones, then you have to make sure you arrange them. You do it y and what? X. Okay, so that's how you do it. Then the next thing we'll just look at, I think these ones are straightforward. Multiply. Let me call it mul, and tf dot multiply for multiplication. AB. And then I'll just call more. Where is it? A is not. Oh, wow. Sorry, guys. X, Y, why am I? So the same thing, it will multiply them one after the other. So 4, 1 is 4. And the last thing we'll do is division, which is equal to TF dot divide. You can do X, Y, and it will do the division for you. Okay, so that's it. It will perform the division and return it for you. Okay, so guys, that's it. This all we'll cover in this particular session. Other teachers will come in from tomorrow and tomorrow next and teach you other fun projects. But before you continue, this is the basic, and you have to make sure you understand these things. Okay, If not, you have some difficulty understand bigger concepts, or you'll be someone that can only use those big function or algorithms without knowing what is happening at the back end. Okay, so this is the basics, and this is even very easy. You can see all these operations are very easy. It's something that you can comprehend. You can just learn them in 2, 3, 4 weeks or a month. There are more beginner level steps you can learn, but this is the most important thing, and I'm assigned to take you guys through it. So that's let's say kind of all. I'll format this notebook well and share it with you guys. Maybe I'll add more comments to it, explaining some of the things, and also share it with you. Make sure everyone gets it in the group. So that's it. I can now stop sharing, and I'll say thank you guys for joining. I'll take your questions, and that's it. So we are back.
Thank you very much, classes, for looking us the introduction to TensorFlow. We have really gone to explain how you can use TensorFlow and getting started with TensorFlow, installing TensorFlow, setting up GPUs, addition, subtraction, and other operations with TensorFlow. Okay, so far during the session, do we have any question? Is there any question we had during the session? Okay, so we don't have any question. So tomorrow we are going to continue this bootcamp by 3. Tomorrow the time is by 3 p.m. What because our speaker will be talking up by 3. We're looking at building an image classifier model instance of. Okay. So I'll be able to get the links to the slides and recordings. I'll drop a link in the chat section so you can join groups so that we share to your email. Okay, let me.
Hello.
Yes.
Okay, so since there are no questions, I think I have some other meeting. I'll join. If there is something, just you guys can just put it in the group, and I'll reach out to you guys.
Okay, thank you very much. So since there's no question, we are going to end the bootcamp for today. Yeah, thank you everybody. Cheers. Bye. So we can meet before.
Thank you so very much.
All right.